A rotary shaver, common type of thing, quite a lot of them about. This one happens to be from, I don't know if we can see it or not, I zoom in a little bit there. Where are we? Tesco shaver, model number SH16, 5 volts at 1000 milliamp. That's 1 amp, isn't it? So it's chargeable. Has a charger on the bottom here, and a screw hole there. If we zoom back out a bit there, then we can see that that has a screw hole there, come up to the top, and it's very difficult to get to the top screw hole. We have to take this bit out here. This actually goes on into 2 slots here and here. I've left it out because, as I say, prizing it out seemed very difficult. The slots on the top, the hooks on the top, seem to be quite robust and haven't broken, so I seem to have got away with that. So once we've taken these 2 screws out, then hopefully it comes apart reasonably easy. If we take it from the bottom, then the top tucks in at the top there, and then it comes away. That reveals us then an electric motor and a cell here, a lithium ion 3.2 volt cell, 600 milliamp hours. Looks like there's room. In fact, it could have actually had 2, but it certainly isn't designed for it on this circuit board. To get the circuit board out, then we can take the top, and then we find there's a hole here that should have a screw in it, but of course I've taken out in good Blue Peter fashion. Take that out, and then the circuit board just comes out, and what we've got then is the motor up at the top. If we look at the motor, oops, wrong way round, we can see it's a 3.2 volt motor wired then onto the circuit board, and at the other end we have the charging socket here, which comes onto this board. If we look at the board itself, let's zoom in a bit. What can we see? Perhaps too far, perhaps not that far. What can we see here? Well, coming in at this end then is the charging end. We have the end here where the cell's soldered through, and the cell's soldered through at this other end here. We have a diode here, which then presumably, if we could get it the wrong way round, charging, would stop it damaging the circuit. We have a couple of transistors here, and a microcontroller here. Lots of discrete components, and here we have the switch then, the on-off switch, and up at this end going out to the motor we have this tiny little gizmo here, which I assume is a couple of FETs, which are actually wired in parallel, and they're an 8205, and they then seem to be used to drive the motor. If we want to look at the circuit diagram, then what I've done is to take a photo of that. We may need to zoom in a bit, and well, it's about right there, is it? Taken the photo, gone through all the wires, not that bad because it's a single-sided board. Can see where more or less all the wires go, and drawn those in, and then change that into a circuit diagram. So here's my circuit diagram, a bit crude, but it shows me what I want to know. Essentially, we have the test points. It's very good on test points. So the charger comes in here with a resistor across between the two. That then comes into this resistor, which comes down onto this resistor, which then goes into this transistor here. And this can also be controlled by pin 5 of the microcontroller. This transistor then is used to drive this, whatever it is, because I can't work it out. but this is labelled as MOS 1. So, and it's also on the circuit board, and the component itself is A1 H8, but I can't find anything about that anywhere. We then have a load of gubbins here, which I assume is something to do with charging and working out what the particular voltages are at any particular time, and those then feed back into a number of pins on the processor. Across here we've got a capacitor, and that then is each side. Pin 1 of the processor, then we've drawn it sort of down here. Pin 1 we think is positive, pin 14 is 0 volts, and then the other wires are connected onto it. If we come across further, then we have our LED which flashes, and that's flashed by pin 2 down here. Across here we have a voltage divider which go to pin 12, which presumably then tell the processor what the voltage is on the cell. We then come across to the button itself. So here we have the push button pulled high by R16, and that then goes to pin 4 here on our microcontroller. We have a resistor here that just goes to pin 7, the function of which defies me at the moment. And down here at the bottom then we have the control for the motor. We have our sort of dual FET sort of arranged in parallel, so both drains connected together, both sources connected together, and both gates connected together. The gates then being controlled from pin 6. Down here somewhere pin 6 goes to the motor. And we also have a couple of resistors down between the source of the FET and the 0 volts. And those then I assume are used to measure the current going through the motor. So if it gets too high, if it gets stalled, jammed up due to too much gunge in there, then these will register, and that will hopefully switch off the motor so that it doesn't overheat or destroy the FETs. So yeah, that's the circuit diagram. It does of course have a diode across the motor, presumably for the back EMF, and a little capacitor as well. So that essentially seems to be the circuit, and that's as far as I've got with that. If I want to actually look at this, then what we could do is to take some measurements, see what we can find out. So what I'll do first of all is to plug it in, and I found it confusing, this socket. I hadn't used it for a while, and when I came to it I thought, looks like a main socket. This is actually a 240 volt main socket, and that is the socket for the shaver. If I try to put them together, however, this main socket doesn't fit, although it looks like maybe it could. The actual socket then has a little blip in the side, although some mains connectors like this have a blip in each side as well, so they look like they could fit but actually don't. So let's plug it in and hope it doesn't go bang. Got to get it the right way up, and if we plug it in, can we get there? Let's see. Yep, in it goes. And when we've plugged it in, we find that the light flashes, assumingly telling us that this is actually charging. Okay, let's see if we can make some voltage measurements on this. So if we put it on our voltmeter, can we see it? Put it on the voltmeter there. Bit of blue tack just to hold it in place, and then can we zoom in a bit? Needs to go a bit higher, does it? A bit closer to the screen, a bit up there. So hopefully now we can measure some voltages. I need to turn the voltmeter on and need to find the leads. So what we need to do is just come a bit that way, get this fastened a bit better. Oops, oh, big bang. Let's try again. Not doing very well here. Let's see if we can do that. There we are. Well, almost. Bumbly 1 and Bumbly 2. So there we can see the voltage and hopefully see the PCB. If we come round to this side where the volts are coming in, if we measure the voltage across, let's try TP2 is it, and the top here, hopefully we can see we've got 5 volts coming in there. If we measure to this side of the diode, it's down to 4.8, so that all seems to be okay. If we look at this transistor here, which we think is our NPN, if we touch this against here, it looks like we've got 0 volt on the base, so therefore on the collector we've got 4 volts on the collector, which presumably is switching on this gizmo here, whatever it is. And when we look at that, shows us with 3.5 volts coming out of there. So that's that part of the circuit. If we have a look on the circuit diagram again, that's up here. So that's this unknown device, this MOS1, which is giving us out 3.5 volts. If we then come to the processor, which we have here, so if we are to try and touch to the pins, it looks like TP1 is the top pin, and this can touch the, hopefully can get this on and try a better connection there. Looks like I've only got 2.2 volts then, or have I got the wrong pin? Is it not TP3? Do I need to go there and there? Yeah, so I've got 3.4 volts across the processor itself. If I want to go to the, use that as 0 volts. Yeah, 3.4 volts across the processor. Come up here to the input. Kind of move across a bit without destroying everything. Come across to the positive of the battery. Seems I've got 3.4, 3.48, 3.47 on the battery. So that still seems to be charging. And then if I want to go to the motor, that's motor negative, so that's not going to tell me anything. Motor positive here. If we can get a good contact, that's got 3.4 volts on it, but motor negative has nothing on it yet because it's turned off. If we turn it on, it's now on, our light's gone to constant, and if we touch that motor contact there, that says 0 volts. Now, which does that mean anything? If we come across, touch the motor there, where's the pin gone? There. and it looks like about 2.67 volts across there. So yeah, and then down at the bottom we have these two resistors here which are dropping the voltage so that processor can measure that if they're in parallel. So if I put that across there, can't see the voltage anymore, try and get that across there, and there, and they then presumably are sending some voltage back to the processor to tell it the current through the motor, and if it gets too high and stalls, then these two resistors R14 and R14A will get a bigger voltage across them, a larger voltage across them, or a smaller. Anyway, the voltage across them will change, and that will then signal back through R12 to pin 13 of our controller, pin 13 here to test the motor, and that then assumedly will switch off the motor, hopefully, if it gets stalled. Don't want to try that, so I'll leave it at that. So yeah, a very interesting sort of circuit board to go through, sort of thing that I love looking at and love finding out about. All I've got to do now is hope I can get it back together again in one piece, and then I'll be able to use it again. Yeah, so it's bye now, bye.